6 pulse converters. Because of the requirement of special type of conversion transformer, 3 pulse converters are not popular. The conversion transformer is used to prevent demagnetization for large outputs and least ripple content. A 3-phase control rectifier with higher pulse number is used. Generally, for industrial application, 6 pulse and 12 pulse converters have been used. Two 6 pulse converters are connected in series to form 12 pulse converter. 6 pulse converters are used in industrial applications and 12 pulse converters are used in HVDC transmission. Advantages of 6 pulse converters are: requirement of series inductance is less, magnitude of ripple is less, probability of discontinuous current is less due to the reduction in lower order harmonics. Distortion on the input side is reduced. Commutation is simple. Now we'll see a 6 pulse midpoint converter. Now this is our circuit diagram, whereas this is our phasor diagram. Now this is also called double state control rectifier. Now this is an extension of 3-phase half-wave circuit where each thyristor conducts for 1/6 cycle. Each SER conducts for 60 degrees, and hence the iteration factor of SER and the secondary winding of the transformer are poor. These converters are also called M-6 converter. The output voltage contains 6 pulses for each cycle of the input voltage waveform. If the R phase is positive, then T2 can turn on. If Y1 phase is positive, T1 can turn on, since T1 is in forward biased. And if Y is positive, T4 can turn on, R dash is positive, T5 can turn on, B is positive, T6 can turn on, as these thyristors are in forward biased when the supply connected to it is positive. Now, each thyristor can conduct maximum period of 60 degrees. SARs are triggered in sequence of T1, T2, T3, T4, T5 and T6 at 60 degrees interval. When thyristor T1 is triggered, and it will conduct until the T2 is turned on. When the T2 is turned on, T1 is going to turn off by the natural commutation. Similarly, this is going to happen for every thyristor. If the load is RL, 6 pulse midpoint converter with RL load, in that case, the presence of an inductor at the load prevents the load current from being discontinuous for any delay angle. If the load time is constant, that is L by R, and the larger than the period of the supply frequency. Now let us draw waveforms for 6 pulse midpoint converter with RL load. As we know, the R by B 3-phase supply is represented like this. Then to make this as 6 pulse R dash, Y dash, B dash. Now we got the 6 pulse. Y dash is connected to T1, R is connected to T2, B is connected to T3, Y is connected to T4, R dash is connected to T5, and B is connected to T6. If alpha equals to pi by 3 radians or 60 degrees. This is each unit is 30 degrees, so 60 degrees. Now the T1 is turned on at 60 degrees and continues to conduct until the next thyristor is turned on. Next thyristor is going to turn on T2 at 60 degrees. So here T2 is going to turn on. T3 is going to turn on after 60 degrees. Here T3 is going to turn on. Next, after 60 degrees, T4 is going to turn on. Next, 60 degrees, T5 is going to turn on here. Now T6 is going to repeat here after 360 degrees, which is nothing but 0 degrees. So here T6 is going to turn on. Now if we redraw that, T6, T1, T2, T3, T4, one cycle, that is 360 degrees or 2 pi radians, where we are getting 6 pulse continuous operation. If alpha equals to more than 60 degrees, that is pi by 2, let it be 90 degrees. Here T1 can turn on, but after 90 degrees, which is this is 90 degrees. here T1 is going to start conducting. Since highly inductive load we are having, even though the voltage given to the thyristor is going to be negative, the thyristor is going to conduct until the next thyristor comes into the operation. So the next thyristor is T2, which is going to conduct after 90 degrees, which means from here to here it is 90 degrees. So here T2 is going to conduct. So the resultant will be like this. Now T2 is going to conduct until the T3 is going to turn on. T3 can turn on here. So from here to here 90 degrees, here T3 can turn on. Next T4 can turn on after 90 degrees. So this is T4. Next T5 can turn on here, and after T5 is going to conduct here. The negative part comes here, and here T6 is going to conduct. So this is the resultant voltage in case of 90 degrees. Now let us redraw that. T1, T2, T3, T4, this is T5, this is also T5, this is T6 average value. I'm shifting this line from here to here. So now we can say this is T2, T5, half of the part is here, T6, T3, T1, T4. Even for alpha equals to 90 degrees, for one cycle we are getting 6 pulse continuous operation. Hence the statement, the presence of an inductor at the load prevents the load current from being discontinuous for any firing angle alpha from 0 to 2 pi 3.